So in order to put holes through the chassis part, what we really want is for the holes to line up exactly with where the gearboxes have the holes. So in order to do that, what we have to do is we can actually edit this chassis part in context, meaning that we're in the assembly, but we can edit it while we're still in the assembly. We don't have to go um, back to the original part. So if we right-click on the part and we hit Edit in Context, now what's happening is we can see the other parts of the assembly, but what we're really changing is the um, is the uh, is the chassis part itself. And what's really useful is you can reference other edges and features of the assembly from here directly. So if what we do is we go to this surface and we do a new sketch, and I hit N to make it orthogonal. Now what we can do is we can hover over these holes, rather, so we can go here and here and here and here. And now what we can do is I can select these two. So this is a sketch. This blue line is a whole sketch, and this here is a edge that exists only in the gearbox part. So what we can do is we can select both of them, select one, select two, and we can hit um, our concentric mate. Yep, exactly. So now it knows that we're editing the context of the master assembly, which is fine. So let's do that for all of these circles. So we want to select here, make them concentric, select here, make them concentric, select here, make them concentric. And now I want to select all the sketches we just made, make these the same size. So we're going to hit E for equal. Nice. And we can dimension these. And I'm going to make them a little bit larger. I think I'm 0.21 inches. Because what these really are, they're through holes. Like the screw has to go through them. They don't thread in. 0.21 inches, that's pretty good. So, and we hit OK here. Basically what we've done is we've created a sketch that has holes that will always line up with the holes in the gearbox. So if, for instance, I were to change the position of where the gearbox is, the holes will move with it. So this is called a reference sketch. And you want to be careful about what you reference and what you don't reference, because things can move in ways that are unexpected if you don't do it very precise. Let's continue editing this sketch. So we're going to hit N to go orthogonal, and we're going to do the exact same thing. We're going to grab circles, and we're just going to draw a bunch of circles. The reason why I'm not putting these circles directly in the middle is because until I define them as concentric, if I were to like put the this dot right in the middle, what might happen is I get confused and I think that they're concentric when in reality they're off by just a tiny bit. So let's select these two, and they're concentric, and let's select these two, concentric. These two are now concentric. These two are now concentric. And let's select all of these. They're all going to be equal. 1, 2, 3, 4. Hit E for equal. Nice. And now we can dimension just one of them. Or what we could do is, now that all of these four are equal, we can make one of these over here equal to like this one over here. And now all 8 are based off of this one dimension. So, we defined all of these as equal, and then we defined all of these as equal, and then we defined this one as equal to this one. It's sort of like a transient property of equalness going on here. So now if we wanted to change the size of the holes, we just need to change one value. We can go 0.25, and they change over here as well. So again, design intent, it's nice to group things together that are going to be the same. So we'll hit OK here. We're going to do our remove extrusion, and we're going to use our sketch, and whoops. Okay. So we click on our sketch, and yes, we want to merge the scope. So sometimes if it doesn't want to build stuff, just click merge with all, and it will just solve it for you. And that has created holes exactly where the gearbox holes are. Very good. So we want to do the same thing with this gearbox. So let's go back to, we don't want to go back to the assembly. We want to stay, see, we're still in the part sketch here. You can tell because this is the only thing that's solid. We're going to just edit our original sketch. we're going to create more circles. Select all of them. These came out really small, I wonder why. Yep, those are all equal. Now let's go over here, and we'll make this thing equal to this. Nice. Okay. So, because we added those circles, it automatically added it to our extrusion, which is nice. So now we have holes in the plate, which is awesome. And let's go back to the assembly, and we can see in the assembly, yeah, there's holes in the plate, and there's holes in the gearbox. Alright, so now we've got holes in our plate. Let's add countersinks to these holes. So we can right click and you do edit in context. We can select the previous context, edit in context 1. Very good. And now what we can do is we can go to our chamfer tool, and I think countersinks are maybe like 60 degrees or 30 degrees. Looks like a lot of these screws have 82 degree chamfers. So 82 degrees divided by 2 is 41, so 41 degrees. Very good. And let's just increase this to maybe 2 millimeters. No, 2 millimeters. Maybe even 3 millimeter. Yeah, okay, that's a pretty good size right there. Nice. And we're just going to click on all of the holes. Very good. So now we have some nice countersunk holes here. Now what we can do is start to do a little bit of material reduction here. And actually, I want to add another feature. So when this hammer bot goes to swing the hammer, because the head is very heavy and it's on the end of a long stick, what the whole thing's going to tend to do is it's going to tend to like sort of tilt up this way. So the whole back of the robot, it's going to try to pop a wheelie pretty much. To prevent that, we should add like a tail to the back of the robot here. What I'm going to do here is I'm going to add little channels for what I'm going to call the tails. So let's go ahead and go to the back of the plate, and we can make these tails, I don't know, half an inch wide. Maybe we'll make them wider than that. Maybe make a whole inch. Yeah. And we'll go back here, and we'll maybe put this 2 inches away. No. Maybe more like 1.5 inches away. Yeah, that's good. Yeah, that looks pretty good. Do the same exact thing on the other side. I'm going to make it 1.5 inches away, 1.5 inches, 1 inch wide, 1.5 inches tall. Very good. And we're going to remove this, but we're not going to go all the way. I just want to go maybe half of that thickness, or maybe even just, yeah. So this is 0.375, so we can make it 0.375 divided by 2. There we go. Nice. So there's a couple slots. And now what we can do is we can add 2 parts. These will be identical parts, so let's make a new part studio. And let's name this tails. And we're going to go new over here. create center point rectangle. I want this to be maybe 6 inches long. Let's go for 7. And this will be 1 inch wide. And we're going to make this that 0.375 divided by 2. Very good. And maybe we give it a rib. So I think we made it 1.5 inches. So let's go new sketch. And this is going to represent where it attaches. So I think that was also 1.5. And we're going to make this for construction. And now we're going to do a nice center point rectangle. And I'm going to go from here to here. But I don't want it for construction, so I got to unclick that. And it's going to extend all the way down. And I don't want this part to be ribbed. And we're going to have, I don't know, 0.25 seems about right. And we'll extrude that upwards, but we don't want this part. And do like 0.5. Yeah, that looks pretty good. Okay. So now we have this tail, and let's go to our master assembly. And we're going to insert that part, tails. And I want to do a planar mate. So I want this plane and this plane to line up. Nice. And now I want this plane and this plane to line up. Okay, good. And click plane again. And I want this plane and this plane to line up. Nice, there we go. So you could probably insert this, in here and then use like glue or something to make that fit nice. Might have to sand down the edges of the 3D print here, but basically, if you have these two, these two ribs, what it can do is it can essentially make the robot more stable. And now, for instance, if I wanted to shift the position of this rib, right, I can edit in context this part. I can go down to where we made that sketch. I can find this dimension, and I can move it over a little bit. 1.75, that's good. And I'll do the same thing here, 1.75. Nice, and I'll go back to the assembly. And everything is moved over. So pretty cool there. So basically, if we didn't have these little tails, what would happen is every time that the hammer swung forward, there'd be a torque, and then the whole thing is going to want to do a pop a wheelie. This pretty much, they're like wheelie bars, I guess. Prevents it from popping a wheelie. So we need to add our second one in here. We're going to insert another part, the exact same thing, our tail rib, just like that. We're going to go planar mate. We're going to grab this surface over here. We're going to grab this surface over here. Those are now mated together. Another planar mate. From here to here. Excellent. So yeah, this is a pretty good. So the reason why I split this up instead of making the whole chassis a larger part is because I think there's a limit to the size that you can 3D print, and I'm trying to keep this as small as possible so that maybe you could 3D print this on a single large format printer, or you might have to split this thing up into two different parts and then glue them together or fasten them together somehow. But this really is how I guess you would build it in real life if that's what you were doing with like metal or something. So You wouldn't buy a whole piece of sheet metal this big and then mill out all these. You'd make the plate and then you'd make the wheelie bars and then you'd put them together. All right, nice. So let's do some good old-fashioned weight reduction here. So you know, for 3D printing, it's important because then you don't have to use as much material. And in robotics, robot combat, it's important because you have got a weight limit. You really wouldn't want to have this full, thick, 3/8 inch plate of aluminum if that's what you're going to make it out of, because it'd be way too heavy. And it's pretty unnecessary. Really, what you just need the parts that are supporting everything else. So let's go to the chassis part again. Nice. And let's go to the top view. So we can see all these holes over here. We go view normal to, and let's do a sketch. And now what we can do is we can actually select these outer edges, just like this. And we can hit the offset tool. Oh, first let's do convert. So convert makes lines that don't exist in the sketch yet, but that you can click into lines. And now let's click on these lines again. And let's select, this is the offset function, and we can change the direction here by dragging it in the opposite direction. Good, and just hit OK. And now we can edit this sketch, and we can actually edit this dimension. So we can make this, I'd say 3/8 is a good rule of thumb for the thickness of a beam. I actually don't know how it will work out with 3D prints, but it's just general good. Actually, let's just make it a 1/2 inch. Why not? Pretty good beam thickness. Okay. So now what we can do is go kind of over here, go down, and use another line, kind of go over here, and go down, and we can make these the same length, make them equal, and we can dimension those. Sure, I think 4 inches looks fine. And it wants the height here. See how they're still blue? They haven't been defined yet. But then once I put in a dimension, now it thinks that it wants a certain height. So I wonder why I wanted that. If I change this, will it freak out? No, it won't. Okay. 3.75. Okay, so that's not really what I want. Just hitting Control Z to undo all this. What I really want is for this to be the same distance. Yeah, that's fine. Well, no, what I really want is for this to be 0.5, right? Yeah, there we go. So that now this whole beam thickness will be 0.5 inches. And if we make this thing equal to this thing, then we'll just hit the same thing on the opposite side. Sometimes it's just easier to draw the geometry and then make them equal than it is to mirror everything. Especially if the part is a little asymmetrical, so like over here we probably wouldn't do the exact same thing. So that's one part, and let's keep going here. I'm actually gonna leave this region as mostly intact, and the reason is because there's gonna be a battery pack that we got to put here. So actually, let's hollow it out just for the sake of it. We're going to use corner rectangle. We'll go over here. We'll make another pocket. We'll make these two line up by selecting them, and instead of doing parallel, you can actually do collinear or vertical. So now these are lined up vertically. And we can make this, I don't know, this looks like it should be maybe 3 inches. Okay, but now it moved it further downwards. So what we really want is for this to be 1/2 inch. Good. And oh, it must not have gotten my. Oh, they have to be collinear, not vertical. My apologies. Yeah, I think you just make them coincident. Yeah, coincident is what you want. Okay. All right. So black square means it's been fully defined. So Let's leave the back part alone because that's we know we're gonna have the tails piece of the robot back there, with the wheelie bars. So let's put in another pocket, maybe right here. Yeah, that's good. And we'll have this beam thickness be 0.5, and we'll have this be, I don't know, 1 inch apart. Sure. And actually, instead of doing that, we should really make this line up with this. Oops. Okay. This, coincident. Yep, that's the same thing because this distance here is defined by how far apart this line is. So let's make this. This looks about right. Yeah, 1 inch. That's okay. Actually, maybe we want a little bit thicker of a beam here where the actual motor is attached to the weapon. Yeah, that looks pretty good. Okay, and let's just do one more of these right over here. This can be a really thin one. We don't want stuff to be too thin. Again, we're going to make this and this coincident. We're going to make this and this coincident. And the thickness, I think maybe we'll just have this be sort of thinner. We'll have this and this be coincident. Yep, so those are lined up. And that's looking pretty good. Maybe we can put in another pocket just like right over here. And it doesn't have to be fancy. You can just make this 1 inch. Nice to use round numbers because then you just don't have to worry about it. Easier to read, easier to type. Oh, okay. See what I tried to do there? I tried to over-define the sketch, and it throws an error because this is already a dimension that is known. So I tried to dimension something I should not have, and it will flash red and scream at you. So good, and distance here we really want this to be 0.5. So yeah, these dimensions they add up pretty quick, huh? Yeah. So basically, now what we want to do is we want to select all of these regions. So 1, 2, 3, 4, 5, and 6, and extrude them. As a removing them. Right, exactly. So we're removing them, and they're going down 1 inch, which is more than the thickness of the plate, which is fine. And just click OK. So now we have a like a plate with beams. Yep, looks pretty good.